Right, good afternoon, folks. In the next while, I'm going to hope to show you how, with a little help from my friends, that I put together a small model tramway. Those of you who know me know that I have a rather wide interest in topics related to transport on rails. Trains in a variety of scales from OO, HO, O gauge, and even G scale. Not content with that wide spectrum of modelling in which I was already involved, along came tramway modelling. Nothing serious, I would hasten to add, as my modelling takes on the view that the models I build look good to me and are not necessarily to scale and are quite likely not representative of, but are symbolic of a prototype. First of all, I found a sheet of perspex, or rather two large sheets of perspex, in a skip near a house undergoing refurbishment. I went to the builder and he was happy for me to repurpose the material. An hour or so was spent, as you see here, cleaning the sheets of plaster and other foreign materials. This would be used for the stiffening board as a base for my model. Neither of the persons shown in the picture here are me, so scraping such a boring task that I would let any volunteer take part. For the top layer of the baseboard, these two large pieces of wall insulation board were found. Source was that the house builders skipped once more. These boards were attached to the perspex board using the very useful no more nails adhesive. To prevent material breaking off the edges of the wall board, I had perspex facing strips fitted around the edges. Again, use of our friendly no more nails. It gave a perfect join and did not eat the surface of the wall board as some acidic-based adhesives do. The edging strips were not available in my friendly builder skip, so I reluctantly spent some money in the local B&Q. Now, this is definitely a category I say, do not do this at home. The layout was being built on two boards, which would be displayed end to end when on display, forming a layout some 8 foot by 2 foot. I'm still in the old measures. I quickly discovered my perspex wallboard composite provided no suitable fixing for the metalwork to hold the two boards together. So things had not worked out too well so far. An emergency solution was necessary. A length of 2 by 1 timber was cut to the width of the board, not the way you should do it here, and attached to the underside of the board at the end. No more nails to my rescue once again. With these cut timbers at the end, a metal fixing strip can be screwed on. First action in any layout is track laying. I use standard Pico 00 track code 100, including set track points, which you see here. In fact, most of my tramway would represent street running. This was simulated by inserting 2mm cardstock cut to the contour of the track. The cardstock was laid to the edge of the sleepers on the track and a second layer laid on top of the first and over the sleeper ends to end up butted onto the outside of the rail. Point motors can be a problem. They can be essential pieces of equipment, but in my case, the ultimate aim is to automate the running of the trams. Positioning a point motor can be done easily by mounting it in the special bases provided by Pico, and these can be clipped to sprues designed for the purpose on the point. This is, however, very obtrusive and not recommended for scenic areas. The alternative, as here, is to place the motor under the point, mounted in a hole in the baseboard. With my chosen shortcut in baseboard building, that was not possible. Again, a problem with the way I've chosen. The answer is to surface mount the motor where it will be covered with scenery. The connection to the point is then made with a length of brass rod sunk into the top surface of the baseboard. At last, a useful action for the use of the wall goal. All that remains to make this tidy is for the base of the building or other feature to be cut and structured to place over the ugly motor. Now nice and neat. All is now shipshape and ready for surrounding scenery where roads, pavements, etc. can be applied. Trolley poles were the next requirement. I looked through catalogues but found the commercially available equipment for the overhead would cost more than I would intend to spend on the whole project. I remind you here of my wavering interests. Today, my G-scale garden project. Tomorrow, the kit building of my O-gauge Stania 264 tank locomotive. And the next day, my HO Canadian switching layout, shunting in our language. The solution was dowel rods, off to B&Q for a bundle of large diameter and a bundle of small diameter dowels. A hole drilled at the top of the large diameter rod and the small rod pushed through to form the outreach arm. There we have it. Worked quite well. Let's add some urban sceneries amongst which the trams will run. Firstly, I applied a back scene. This was a sheet of fiberboard, which is widely sold in hobby shops. It consists of foam inner layer sandwiched between two sheets of card or of thin plastic. The sheet, painted sky blue and given patches of streaked white applied with a hard nail brush to break up the blue and hopefully, with not too much study, to make it look like clouds. This was mounted vertically to the rear of the model and stops the viewer's sight line. Immediately in front of the back scene are placed low-relief structures. A low-relief building is frontage only and a depth of only a few millimeters. In this picture, the street scene has been created along the back of the layout, and a row of full relief buildings has been placed in front. The result is the creation of a three-dimensional effect. It's easy to forget that the rear of the properties in the front row have their backs directly onto the street behind. Most buildings in the view we have are constructed from card kits. On the first public display, this was the plan, and models were borrowed from friends and layouts. For future appearances, I will be augmenting these or replacing them, returning them to their rightful owners. They will be replaced by screen scenes, print yourself kits. I'll elaborate them on a little later. Sorry about the steam locomotive in the foreground there, but it was the only thing available when I began electric testing. Quite a varied scene can be created with these building structures. And this is where it all began. A friend gave me a Beck's kit of a London tram, complete with motor chassis. The bottom deck had been assembled and painted. He had lost interest as the motor bogie did not run very well. A very small amount of tweaking of the pickups on the motor and bearing them on the back of the wheels, and all ran smoothly. The top deck was assembled, then passengers passed the complete model onto a second friend to have the top deck painted to match. Pictured here in its pre-final paint job, it ran back and forth on my Canadian model railway in my home garage. Here we have that same tram on my developing tramway. Now what I needed was more trams. The detailed and scale kits were a bit too dear for what would be my short-lived project. I turned my attention to the sales of porgy trams. on eBay, of course. Here are a couple repainted in Glasgow Corporation colours, sitting on a part-built tramway. Of course, they needed a bit more work beyond the repaint. A motor bogie was an essential, as I wanted to see them run. I had a few Black Beetle motor bogies, which had initially been bought by the Clydeside Model Railway Club to power the 3-class 303 electric multiple units. I had assembled them from kits for the club. However, the motors were not powerful enough to drive the 3-coach trains and were ultimately replaced with Hornby motor bogies stolen from HST sets. A short negotiation and a few pounds went into the club's coffers. So, tram body and Black Beetle motor, all to be done was fit them together. Before I move on to how the body and motor bogie were put together, I had a wee look around the market. Tenshodo and Black Beetle motor bogies were in the 30 to 40 pound range. I say were because they are now difficult to find at all. In view of that, slipping £20 per motor into the club account was good value. During the search, I came across a kit for a motor bogie, only £12.73. Now, of course, it's £13.99. When opened up, it looked rather daunting, but in truth, it was easily assembled. The gearing, the axles, and the motor were all contained within a plastic channel. This, after a very short time, buckled under the weight of the Corgi tram ball. You can see the chassis bending at the end. Fortunately, a friend of mine who's equipped with a workshop was able to source a metal, I think it was nickel silver, piece of channel, and could drill holes squarely for the axles. Job done, back to eBay for another Corgi, ideally in Glasgow Corporation colours. That's the underside of the assembled motor bogie. Fitting the body to the motor presented a few challenges. The first was how to get inside the body of the tram. There is a tiny screw, if anyone wants to do it, at the end of each upper deck. With the tram in parts, it gave me access to the top of the chassis. A rather labour-intensive job followed. The size of the opening required to house the motor bogie was marked off, and by drilling a series of small holes through the thick die-cast metal around the marking followed. By using a small file to cut between the holes and so open up a rectangle in the base. A shaped piece of brass was fitted to either side of the opening, raised in the centre to give the required height of the body over the motor, and attach the motor by means of its centre mounting screw. Add a few little people to the top deck, and then, before reassembly, put a few more little people on the lower deck. The people down below were given an amputation to their legs. The motor had taken up most of the space below the level of the seats, so fitting with no legs was the only way. It's not noticeable other than at very close inspection. Next challenge was the characteristic bow collector for the roof. I did buy a brass fret to make a scale representation of this. Unfortunately, it was not robust enough to withstand the rigors of being dragged along the overhead wire. A chance comment to a friend about this dilemma provided me with information that Glasgow Corporation fabricated their own using gas piping. The way forward was to emulate that with 1mm brass wire. I drew the shape on a block of wood, inserted some pins where the bends and the cross pieces would be, and soldered the lot together. For the pivot arrangement, I bent the bottom of each leg outward and inserted them into an aluminium strip across the roof, which was given upturned lugs with holes drilled to house the legs, clearly seen in this picture. For the upward springing of the bow, a phosphor bronze strip was anchored along the roof surface with an upward crescent-shaped loop bearing on the underside of the lower crossbar of the bow. That's quite a mouthful for me to say. And I must say, I was very surprised, having read an article about this, that it would work, but it does. With the bow complete and with a small dropper soldered to the overhead, at a terminal, the bow should automatically flip on car reversal. Hopefully, I can show you this action. Sometimes this works and sometimes it doesn't. Here we go. Since I'm so satisfied with how this works, I'm going to visit that scene again. Bear with me, it's for me, if not for you. I showed this scene to a friend of mine and he said, trouble is, the bow flips over, but the driver doesn't change ends. And there we have it. A simple little piece of wire on the wire, and there we are. My thoughts now turned to how difficult it would be to build a 4mm scale tram from scratch. The procedure of drilling out the substantially thick floor of the Corgi trams models was not one I enjoyed to any degree. Scottish Transport, the magazine published by the Scottish Tramway and Transport Society, carried an article about the Paisley lightweight trams in one of its editions. The article, credited to David Bowler, as part of the text and photographs, there was an outline drawing with dimensions. The size of the print on the drawing was very small and called for interpretation in some areas. Iconic as it is, but the author with whom I was in fairly regular communication at the time told me he had a large copy of the diagram, and had he known my intent, he would have been happy to provide it. Unfortunately, the project was too far advanced. Isn't it true? Everybody wants to help you once you've completed it. There were only 5 of these actual trams built for use in the Glasgow area, and were in fact seldom seen other than in the rush hours to augment the fleet, and then seldom beyond the Paisley tracks. It was one of these 5 cars I regularly rode from my home to my apprenticeship work in Balcock and Wilcox or Renfrew. I can think of no better reason to attempt to build one of these cars. The body is constructed from 2mm thick plastic hard in 4 pieces, 2 sides and 2 ends. The floor for both lower and upper decks were also from 2mm thick plastic hard. The roof was shaped from a piece of balsa wood with ribs around the underside edges. These gave a tight fit on the assembled sides. The upper deck floor was seated on a rib which ran round the inner of the top of the lower deck. A hole was made in the center of the top deck floor. This, by using a small pointed tool, the floor can be levered out to give access to the lower deck and the Black Beetle motor setting. A control panel was built for the layout. From this, you can see how simple the layout is. The panel showed the various sections into which the track was divided, each with its own on-off switch. This way, several trams could be on the model at any one time. In practice, to give a free movement for each tram, a total of 4 cars was the most practical. To operate the points, a switch was added at either side of the layout, and either side of the layout name, that is, for these to be manually operated. The model was taken to a 2-day public display in this state of manual control. The report from our operating team was of a sore neck, akin to that of the swiveling of your head at a tennis tournament. The stage was set for automation. Yes, this was the difficult bit. Here once more, we have the track plan. The X's on the plan signify where would be located magnetic reed switches, which would power the relays controlling the layout. The rectangular portions were locations where the trams would stop. It was run to a sequence of 4 trams when run manually. At times, it was hoped to run 2 trams simultaneously. I would use 2 controllers, both preset, one to drive the trams left to right, the other to drive them right to left. In practice, the 4-car dream defeated me, and a 3-car sequence was introduced. I'm hoping my diagrams which follow will give you an idea of what the 3-car running has evolved to. Here we go then, 3 trams represented by a red, a blue, and a green panel pin. In start positions, because there isn't really a start position, this is a continuous running layout. In the start positions, the red and green are stationary at the termini. Blue is moving left to right. Blue crosses and activates reed switch A, which sets the red tram in motion. Blue then comes to a stand while the red car continues on its way. Red passes contact B and changes the point on the right and sets blue in motion again. Blue comes to a stand at the terminus while red continues on its way. Red then crosses contact C, which changes the left point and sets green in motion. Red comes to a stand while green continues. What follows is a continual movement of the trams, and we will just step through it fairly quickly. If you follow red, you'll find it is making its way back to its original starting point in the terminus. Now, what makes it happen? This is a schematic of the switching required. The squares are locking DP-DT relays, which provide ample switching power for the operation of the trams. The 2 controllers allow a setting to be made with one controlling movements left to right, that's the one on the right, and the other controlling the movements from right to left. One person supervising a running session tells me that the left and right controller should be left and right on the diagram. Excuse me, I'm quarry-fisted. In any event, the track power at either end is switched between the controllers, but that on the double track is dedicated to just one controller. I drew a small diagram of how the switching in the locking relays works. The bottom 4 pins being the contacts to drive the relay, the top 3 on either side being the activation of the changeover contacts. I present this diagram for no other purpose than when I drew it, they looked like funny faces. So, a detailed view of the pins on the relays is laid out here. No electronics, just pure switching. Of interest here are the 3 pins on the leftmost and rightmost relays. These control the switching of the track points at A and at D. The inclusion of a connection via a capacitor gives me the chance to use an on-off switch, in this case, the switchover contact in the relay itself, rather than push buttons and the related momentary contact. An old 1960s or even 1950s technology provides the point switching circuitry here. The 2 coils on the left represent the motors in the pico point motor. When the switch in the center, which is located on the double pole, double throw changeover relay, when that switch is in the upper position as shown here, the current flows through the upper coil, thus driving the pico motor. It then passes through the capacitor, which it charges to capacity and stops the current flow. Switching the switch, again, inside the relay, to the lower of my diagram causes the capacitor to discharge through the lower coil, so changing the setting of the pico motor once more. This has worked well on several layouts I've built, and although there are better methods highlighted by Davy, we haven't used them as yet in earnest. Earlier, I promised some information about scale scenes, print yourself buildings. These are available online. The idea being you pay a small sum, you get a key to a file which gives you online details of parts of a building. You pay a small sum, between £5 and £7 per building, and that allows you to build the building as often as you like, depending on how often you print. This is a sample of 2 pages of the parts for a low-relief cinema building. There are 20 pages, not all of which are required, as alternative parts are given, which allows different styles to be assembled from one kit. A comprehensive list of instructions is given in easy-to-follow steps, with many illustrations of each step. It really is a pleasure to spend an hour or 2 assembling each kit. Once printed on your home computer, the parts are cut out and glued to card to give them rigidity. Cards of thicknesses of 2 mil, 1 mil, and 0.5 mil are used depending on the strength required of particular sections. The end result of a few hours modeling can be quite impressive. This kit provides choices for 4 different Odeon cinema frontages and 4 different ABC cinema frontages. I chose one of the latter as I spent some of my life as a projectionist in one of the ABC's cinemas. A trick of Adobe print software allows you to choose your own film titles for the marquee display merely by overtyping the part before cutting it out. The High and the Mighty was chosen because I had my first date watching that film. And Young at Heart, starring Doris Day, because who can resist Doris? On my model, even today, these films are still popular, as evidenced by the queue outside. With the model more or less complete, my thoughts turned to more scratch building trams. The Glasgow Corporation car proved a very difficult model to build. I did not have any drawings of this tram and relied on scaling everything from photographs. The chassis for it, being a bogie, fell into my hands from a clearance shelf on a local toy shop. £6, thank you, for an underground Ernie locomotive from the Bachmann range. The twin bogie chassis was ideal upon which to build the body. The result of my build left a bit to be desired insofar as proper representation of the coronation car goes. This over the rooftops view is the only view that looks not too bad. And there we have it, the Corker Hill tramway model in 00. Thank you for listening, gentlemen. That's it.